Hello everyone, so today I'm going to show you about my physics project titled The Reenactment of the Past. First of all, there's the big question of why do visionary leaders adapt? And there's also a project focused question of how can human analyze transformation based on physics concept and laws in day-to-day life activities. Both of these questions will be answered at the end of the video. There's also two outcomes in this project. The first one being able to develop forward-thinking design based on the understanding of Newton's law of motion. And the second one being able to analyze daily life problem based on the principle of work, energy, and power. So this is my free body diagram. As you can see in this photo, first of all, the force of gravity is pulling me down, but my leg is keeping me up. The second one is I am leaning towards this statue, but the friction prevents me from pushing this statue away. Okay, the next one is Newton's first law of motion, which is stated every object will remain at rest or in a uniform motion in a straight line unless complete to change its line by the action of an external force. This is also known as the law of inertia. As you can see in this photo, if you analyze the paper, you can see Newton's first law of motion, which is inertia. The paper in here is not moving or at rest. But if there is an external force, such as my hand moving, this paper will be moved. Therefore, it is an example of the law of inertia. Newton's second law of motion stated, when a constant force acts on a massive body, it is caused to accelerate. This is also known as the law of acceleration. In this photo, you can see the Newton's second law of motion. As you can see, when a constant force, such as my hand, is moving the headband upward, the headband is also accelerating upward. And the headband will comes out of my head. Therefore, this is an example of Newton's second law of motion. In Newton's third law of motion, it is stated that for every action in nature, there is an equal and opposite reaction. This is also known as the law of action-reaction. As you can see in this photo, if you're analyzing it, if I fall from hanging, I will go down because of the gravity. But it will cause an impact, causing my back to hurt. Because when I fall from the ground facing my back, therefore my back will be receiving the equal opposite reaction of when I'm falling to the ground. This is in conservation of energy, it is stated that energy can neither be created nor be destroyed. So, if you analyze this photo, you can see the data given is the gravity of the Earth is 10 meters per second, and the mass of one people in there is about 150 kilograms. The velocity of a Ferris wheel is 5 meters per second, and the maximum height is about 2 meters. So, based on that data that given, we can calculate the potential energy. If you want to calculate the potential energy, it will take mass times gravity times height, which in this case is 150 times 10 times 2, which is 3000 joule. We can also calculate the kinetic energy, which is half times mass times velocity times 2. In this example, as you can see, we got 1875 joule. So for the mechanical energy calculation, we can both put the kinetic energy and the potential energy. It is 3000 plus 1875, which is the total of mechanical energy is 31,875 joule. So for the big question, my answer is of why do visionary leader have to adapt? My answer is we, as a student, have to adapt in order to face and handle problem that is given to us each day. And the project focus question of how can human analyze transformation based on the physics concept and laws in day-to-day life? My answer is physics concept and law is happening every day. We just have to understand how each law works to truly notice how the world works. That's it for my video. Thank you for watching.